Kia ora Year 12. This video is a request from Ethan, and it's 3 complex numbers questions from the 2011 June paper. It follows on really well from the video that I did yesterday, so you might want to go and watch that one first. So I want you to pause the video and try and work through all 3 problems. So the first one is one where we're given a complex number, and you can see that we're going to have to multiply by the conjugate. We have to find the modulus of u and show that the argument is negative pi on 2. So this bit is pretty straightforward. I'm going to do it quite quickly. So u is equal to 6 minus 3i over 1 plus 2i. So we multiply numerator and denominator by the conjugate. And that gives me 1 plus 4. And then in the numerator we get 6 minus 12i minus 3i, and then it's going to be plus 6i squared, so minus 6, giving us negative 15i over 5, which equals negative 3i. Now the easiest way to do the next bit is to sketch that on an argon diagram. So we've got negative 3i here, and we can see straight away that the argument is negative pi on 2. And if you want to write something there, you could say since the real part of u is equal to 0 and the imaginary part of u is negative. I think you probably don't need to say that much. I think a good diagram is worth doing in here. Okay, so that's the first bit. Now let's look at the next bit. For complex numbers z that satisfy this condition, the arg of z take away u is equal to pi on 4. Find the least possible value of the modulus of z. So we need to do a bit of work first to find that locus. We've rewritten u now, and u is equal to negative 3i. So what does my locus look like? Well, let's just draw a diagram. Let's draw it with a different coloured pen. Let's try that one. So I could have done a pretty GeoGebra picture, but I want to show you how I'm thinking about the problem. The locus that we're looking for here is the arg of z minus u is equal to pi on 4. So that means that we've got a half line starting at u, and u is negative 3i. So we want to go down to negative 3i and draw an open circle, and then a half line that's going up at a 45-degree angle. And if you draw this diagram well, it's going to make the solution pretty obvious. So there's my half line there. Right, what are we being asked to find? Let's go back to the question. So we want the point on that locus that has the least possible value of the modulus of z. In other words, we want to find the point somewhere on that line that has the shortest distance from the origin. So remember, we've got lots of ways to think about the modulus of z, but basically it means if I take any point, it's the distance from the origin to that point. So grab your ruler again, and what we're looking for is which point on that locus is going to be the closest to the origin. And you know from AS and level 2 coordinate geometry that the shortest distance will be where the line segment is perpendicular to that half line. Okay, so what we're looking for is the point along here, which is at 90 degrees from this point here. And that makes this very easy to solve. Now, I've done it by thinking about coordinate geometry, but you can do it using trig or geometry as well. So let's just give ourselves a little bit of space here. We can write the equation of that locus as this. So y is equal to x minus 3, right? It's x minus 3 because the y-intercept is at negative 3i and the argument is pi on 4. That means that we know that the slope of our line segment must be negative 1. So our line segment is going to be y equals negative x. We can draw that in, and that shows us the point that we're looking for. Now you're probably looking at this for the first time going, oh, this is a huge amount of work. But once you've seen the pattern, it's a really straightforward problem. So we've got a little right angled triangle here. And we need to find the length of this line here. So there are plenty of different ways to do that. You can see from looking that it's going to be an isosceles triangle. And so it's going to fit my special triangles pattern of 1, 1, root 2. That's one way to think about it. But as I said, I did it using coordinate geometry. So we're finding the intersection of y equals negative x, and y equals x minus 3. That gives us negative x equals x minus 3, or 2x. Which way am I going? 2x equals 3, so x is equal to 3 over 2, and y is equal to negative 3 over 2. Right, so the coordinate geometry method is good because it will work on more complicated problems. But in here, you can see that pattern just by looking at, I'm just going to take the highlighter. So look at this little triangle here, and now turn it on its side. Right, we know that the length of this hypotenuse side is 3, and we know that each of those angles is pi on 2. So that means that these have got to have a length of 3 over 2 each to make it all add up. I think that works. Maybe not quite. No, that doesn't quite work because I'm looking at the coordinates of this point, right? But what we've got to find is the length of that one. Okay, so I'm going to keep going using my coordinate geometry method, even though some of you are probably groaning at your computers about how inefficient it is. But we've found this point here is 3 over 2, negative 3 over 2, and we can call that point A. Okay, and we can call the origin O. So our job is to find the length of OA. So it's going to be equal to 3 over 2 squared plus negative 3 over 2 squared, which is equal to the square root of 18 over 4, which is 3 root 2 over 2. And that's the least value possible of the modulus. Okay, right, so I've used up 7 minutes already, but I am going to redo that one by simply using special triangles, right? Because the coordinate geometry approach is pretty slow and clunky. So let's take off some of this. Let's not think about the equations of the lines, and let's not worry about the coordinates of that point. And see if I can delete just a wee bit of it. Yep, too much has gone away. Okay, we've lost all of it now. Let's put that line back in here. Nope, big mess. Okay, let's just keep on going down here with some bad drawings. All right, so we've got this line here, and we know that this has to meet here at an angle of 90 degrees. We know that this angle here has got to be 45 degrees or pi on 4. Because angles in a triangle add up to 180, this angle must also be pi on 4, and this length is 3. So now let's turn that triangle around. We've got 3 here, and we want to know that one and that one. And my final answer is going to be the length of that side. So this is just a straightforward similar triangles problem where we've got 1, 1, and root 2. So 3 over root 2 is equal to, call this x over 1. So there's my final answer. X is equal to 3 over root 2, which is the same as the answer we got before, only it's been rationalized. So we've got 3 over 2 root 2. Okay, so it's pretty obvious that the coordinate geometry approach is really slow, but it might help some of you with your understanding. Most of you probably will want to use the similar triangles method straight away. Let's go back up now and look at the second part of the question. So we've got a question that says, for complex numbers satisfying this condition, find the greatest possible value of the modulus of z. The first thing to notice is that we need to do some work on this to simplify that, and then we're going to have a circle. Right, this is a pattern for the locus of a circle. So we're looking for this condition, but we know that u is negative 3i. That gives me negative 3i minus 3i squared, which is negative 3i plus 3. So we can rewrite my condition as z minus 3 minus 3i is equal to 1. And that's a circle with radius of 1 and centre of 3, negative 3. So this is what it looks like. I've drawn this one beforehand to speed things up a bit. What I have to find is the greatest distance of a point on that circle from the origin, right? That's what modulus of z means. So if we take our ruler and we just have a look at where that's going to be, you can see that it will be where I go through the centre of the circle and come out on the other side. So let's draw that line in. So if I wanted the least distance, it would be this point here, but the furthest distance is this point here. And once you see it drawn out like that, it means that this question is really, really easy, because we know how far it is from the centre to this point here. It's a circle with radius 1, so that's 1 unit long. And we know by Pythagoras what the distance is from O to point C, which I'm calling the centre. All right, so OC is equal to the square root of 3 squared plus negative 3 squared, which is the square root of 18, or 3 root 2. So the greatest z value is going to be 3 root 2 plus 1. Okay, so there you go. Hopefully you can see from this that drawing good, accurate diagrams is really going to help you think about how to solve these questions. Let's just go back and have a look at whether we've answered everything, but I think we have now. Okay, so we started off with a complex number that we had to sort out by doing the conjugate thing that we always do. And then we had 2 loci problem, and in both of them we used geometry to help us solve them. Thanks for watching. I'll try and find some more questions that are a bit like these ones.